Good morning, everyone. In yesterday's class, we have studied center of a group and normalizer of an element and their theorems. In today's class, we shall study we shall study the factor of a group or a quotient group. Okay. So in today's class, we shall study factor of a group or a quotient group. Okay. In today's class, we shall study about a factor of a group. Factor group, or you can say this as quotient group or quotient group, quotient group, or you can say this as quotient group. One second. This is a quotient group. Quotient group. Okay. So factor of a group or a quotient group. So till now we have studied this. Till now we have studied about groups, subgroup. From group we taken a subgroup. This is first and this is second. And now after this cosets, right cosets, left cosets, all these cosets. This is third. From this coset, we find out at the value of normal subgroup NSG. Normal subgroup. Okay. So first we have to find out group. After that subgroup. After that cosets, right cosets, left cosets. After that normal subgroup. So by using this normal subgroup, now next we shall find out the quotient group or a factor group FG. By using this normal subgroup, we shall find out quotient group or or a factor of a group. Now by using one second, I will remove this all. Okay. So now by using NSG, by using normal subgroup. By using normal subgroup, we find out the we do the factor group and a quotient group. What is a quotient group? What is a quotient group means? The definition of quotient group is it's by the cosets. It's by the cosets. Let us see the collection of all cosets of H in G. So what they are saying in definition? So definition ಏನಾಗ್ತದೆ ನೋಡ್ರಿ collection. So the collection ಆಗಬೇಕಿತ್ತಾ? So collect ಆಗಿದೆ. Sorry. Collection of all cosets of H in G. So the G, this H is not a, so this is not a subgroup. Idu subgroup il nodri. It is not a subgroup. Okay. It is not a subgroup. It is a normal subgroup. It is normal subgroup. Okay. So it is not a subgroup. It is a normal subgroup. By this H or normal subgroup, which becomes which becomes a cosets. These all cosets. So it is done ella cosets no right cosets, only right cosets. Once again, all right cosets. All right cosets. All right cosets of H. Of all right cosets of H. This is called, this all right cosets of H is called a factor of a group. Factor of a group or quotient of a group. Quotient group. Okay. These all right cosets. So subgroup ಅಲ್ಲಿರುವ ಎಲ್ಲಾ right cosets. So means subgroup ಅಲ್ಲಿರುವ ಎಲ್ಲಾ right cosets ಗೆ ಏನಂತ ಹೇಳ್ತೀವಿ ನಾವು? So let us see subgroup ಅಲ್ಲಿರುವ. This is normal subgroup. Sorry, this is a normal subgroup. From the normal subgroups of all right cosets, we call it as a factor of a group or a quotient of a group. Wait ಮಾಡಿ ಇನ್ನೊಂದ್ಸಲ ಹೇಳ್ತೀನಿ. So collection of all right cosets. Collection of all right cosets of H in G. This is called a factor of a group or a quotient of a group. So means right. So this is not a subgroup. This is subgroup alla. Idu subgroup alla idu. So it is a normal subgroup. This is a normal subgroup. From the all of this, by this normal subgroup, which becomes all right cosets. These all cosets, you all cosets factor of a group or a quotient of a group ಅಂತ ಹೇಳ್ತೀವಿ. So this is denoted by G by N ಅಂತ ಹೇಳಿ ಡಿನೋಟ್ ಮಾಡ್ತೀವಿ. So ಇದಕ್ಕೆ ನಾವು ಎಲ್ಲಾ ರೈಟ್ cosets means ಇದರಲ್ಲಿ H ಅಲ್ಲಿರುವ ಎಲ್ಲಾ ರೈಟ್ cosets means in H ಅಲ್ಲಿರುವ ಎಲ್ಲಾ ರೈಟ್ cosets ನಾವು ಏನಂತೀವಿ quotient of a group or a factor of a group ಅಂತ ಹೇಳ್ತೀವಿ. So H ಅಲ್ಲಿರುವ ಎಲ್ಲಾ ರೈಟ್ cosets, H ಇಂದ ನಮಗೆ ನಾರ್ಮಲ್ ಸಬ್ಗ್ರೂಪ್ ಅದ, ಸಬ್ಗ್ರೂಪ್ ಅಲ್ಲ ನಾರ್ಮಲ್ ಸಬ್ಗ್ರೂಪ್ ಅದ. ಸೊ H ಅಲ್ಲಿರುವ ಎಲ್ಲಾ ರೈಟ್ cosets ಗೆ ಏನಂತೀವಿ ನಾವು ಫ್ಯಾಕ್ಟರ್ ಆಫ್ ಎ ಗ್ರೂಪ್ ಆರ್ ಎ ಕ್ವೋಷಂಟ್ ಆಫ್ ಎ ಗ್ರೂಪ್. ಏನಾಗ್ತದೆ ನಿಮ್ಮ ಡೆಫಿನಿಷನ್? ಸೊ ಈ ತರ ಬರೀರೋ ಡೆಫಿನಿಷನ್, collection of all right cosets of H in G is called a factor of a group or a quotient of a group. ಇಲ್ಲಿ ಬರೀತೀವಿ ನೋಡಿ, is called FG or QG. If you write this much, it's enough. So ಇದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಏನು ಬರೆಯಬೇಕು ಬೇಕಾಗಿಲ್ಲ. Okay. So next, so now we shall see the definition from the textbook. This is not from the textbook of yours. In textbook they have given that. In textbook they have given let G be a group. Let G be a group and N be a normal subgroup. Okay, N be a normal subgroup. Let G be a group and N be a normal subgroup. Okay, normal subgroup of G. Then the set G by N, set of G by N of all right cosets, same of all right cosets, of all right cosets of n in G, n in G, n in G together, together, together with the binary, with the binary operation, with the binary operation, with the binary operation defined by, so how we define this? So how we define means, so n into A, Na into Nb, Na into Nb is equal to Nab for all Na, comma Nb belongs to G by N. Okay, this is G by N. That G was not in the cosets of G, so this is called is called is called is called factor group or quotient group. So what does this textbook definition says to you? Okay, textbook definition says to you that let G be a group and N be a normal subgroup of G. Then G by N, then G by N of all right cosets of N in G together with the binary operation is defined Na into Nb is equal to Nab for all Nab, Na comma Nb belongs to G by N. This is called a factor of a group. So ಎರಡು both ನಾ ಡೆಫಿನೇಷನ್ಸ್ ಇದು ಡೆಫಿನೇಷನ್ಸ್ ಎರಡು ಒಂದೇ ನೋಡ್ರಿ ಏನ್ ಚೇಂಜಸ್ ಇಲ್ಲ ನಾ ಹೇಳಿದ ಡೆಫಿನೇಷನ್ ఏంటి the collection of all right cosets of H in G is called the factor of a group or a quotient of a group. ಇವ್ರು ಏನ್ ಹೇಳ್ತಿದಾರೆ ಫಸ್ಟ್ ಏನ್ ಹೇಳ್ತಿದಾರೆ ಫಸ್ಟ್ ಸ್ಟಾರ್ಟ್ ಹಿಡಿದು ಬರ್ತಿದ್ದಾರೆ ಲೆಟ್ G be a group ಅಂತ ಡಿಫೈನ್ ಮಾಡ್ತಾರ ಆಮೇಲೆ N be a normal sub group ಅಂತ ಡಿಫೈನ್ ಮಾಡ್ತಾರ ಸೊ N ತಗೋಬಹುದು H ತಗೋಬಹುದು the normal subgroup ಅಂತ ತಗೊಂಡಾರ ಅವರು of G do then the set of all G by N of all right cosets. I also said that all right cosets, okay, all right cosets of G in N. ನಾನು ಹೇಳಿದ್ರೆ collection of ನಂದೇನಿದ್ರಿ the collection of all cosets of G in H in G is called the quotient, is called the factor of a group or a quotient of a group. Quotient of a group. So that we define here Na into Nb is equal to Nab for all Na comma Nb belongs to G by N. This is called a factor of a group. Okay. So next, this is your definition of normal factor of a group or you can say the quotient group or factor of a group. Any one of these. Okay. So next we shall move to the theorem. So example number 1. So next we shall move to the example number 1. Example 1. The example number 1. So what is our question? So show that every subgroup of an abelian group is normal. Okay. Of an abelian group is normal. Okay. Of an abelian group is normal. Okay. So the first example of this example series, problem series. So What does the question say? Show that every subgroup of an abelian group is normal. So now it is a question that they have given that abelian group. That they have given that abelian group. We have to prove. We have to prove every subgroup is a normal. So ಏನು ಪ್ರೂವ್ ಮಾಡಿದ್ರೆ ಅಬೇಲಿಯನ್ ಗ್ರೂಪ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು ನಮಗೆ ಏನು ತಗೊಂಡು ಎವ್ರಿ ಸಬ್ ಗ್ರೂಪ್ ತಗೊಂಡು ನಾರ್ಮಲ್ ಅಂತ ಪ್ರೂವ್ ಮಾಡತ್ತ. ಸೊ ಕ್ವಶನ್ ಹೆಂಗ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಬೇಕು ನೋಡ್ರಿ. ಫಸ್ಟ್ ನಾವು ಕೊಟ್ಟಿದ್ದೆ ಅಂದ್ರೆ ಅವ್ರು ಏನ್ ಕೊಟ್ರ ಅಬೇಲಿಯನ್ ಗ್ರೂಪ್ ಅಬೇಲಿಯನ್ ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಸೊ ಬೈ ಯೂಸಿಂಗ್ ಎವ್ರಿ ಸಬ್ ಗ್ರೂಪ್ ವಿ ಹ್ಯಾವ್ ಟು ಪ್ರೂವ್ ನೋ ಇಟ್ ಇಸ್ ಅ normal subgroup, normal group. Okay, normal subgroup. Okay, so now let us prove. Let us solve this example. Okay, let us solve this example. Okay, so let G be an abelian. Let G be an abelian. Let G be an abelian group. Let G be an abelian group. So let G be an abelian group. Let G be an abelian group. Okay. Let G be an abelian group. Okay. Let G be an abelian group. Abelian group and HB a subgroup. HB a subgroup of G. HB a subgroup of G. So and we have to prove here H is a normal subgroup. H ಅನ್ನೋದು ನಾವು normal subgroup ಅಂತ prove ಮಾಡೋದು. So in this question we have to take that one terms of it, x belongs to G and x belongs to G and H belongs to H ಅಂತ. If we have ಯಾಕೆ ಇದು x belongs to G ಮತ್ತೆ x belongs to H ಅಂತ ಹೋಗೋದಂದ್ರೆ so we have to find out that x inverse belongs to H ಅಂದ್ರೆ H ಇದೆ subgroup ಆಗುತ್ತೆ and it is a normal subgroup. So in ತರ prove ಮಾಡಿದ್ರೆ it is a normal subgroup. If we take this we can prove that it is a normal subgroup ಅಂತ prove ಮಾಡಬಹುದು ನಾವು. So already next ಏನು ಓದ್ತೀವಿ. So we take this. Okay. So what we are taking here, let G be a abelian group. Now G ಅನ್ನೋದು abelian group ಇದೆ and H is a subgroup of G. So ಇದರಲ್ಲಿ ಒಂದು subgroup ಇದೆ. So G is subgroup G ಇದೆ ಒಂದು H subgroup ಅಂತ ತಗೊಂಡಿದೆ. So next we have to consider that let x be any element of G and H be any element of capital H. Okay, this both is nothing but, so you have to hang on. So in textbook they have given directly that x belongs to G and H belongs to capital H. So in textbook they have given that directly as x belongs to G and H belongs to G. So in ಮಾಡಿದ್ವಿ so that we have written in a sentence form. Let x be an element of a G. So x ಅನ್ನೋ ಯಾವುದನ್ನ ಒಂದು ಎಲಿಮೆಂಟ್ ಇರಲಿ G ನಲ್ಲಿ. So as usually let H be any element of capital H. So same this as, so our input is same as it is ಬರ್ಕೊಂಡು that we have written in the form of sentence. So ಅಲ್ಲಿ ನಿಮಗೆ confusion ಆಗಬೇಡ್ರಿ. So sir ಹೆಂಗ್ ಬರ್ತಾರ ಸರ್ ಹಂಗ್ ಬರ್ತಾರ ಅಂತಲ್ಲ. So it is a basic and understanding method. So ಆ ತರ ಬರ್ತಾರೆ ಅಂತ ತಿಳಿಯಲ್ಲ. So ಅದಕ್ಕೆ in the sentence form ಅಲ್ಲಿ ಬರ್ತಿದ್ದೀನಿ. So therefore let x be any element of G and H be any element of H. Okay, so next we have we have we have we have okay, we have x h x inverse is equal to x x inverse h. Okay, this is how we take, because so the reason ತಗೊಂಡಿದೆ ನೋಡ್ರಿ, because g is abelian. G is abelian ಇದೆ. G is an abelian, so that hx is equal to ಏನಾದ್ರೆ reciprocal ಆಗ್ತದೆ ಇಲ್ಲಿ, inverse x inverse h ಆಗ್ತದೆ. Okay, confuse ಮಾಡ್ಕೋಬೇಡಿ. So this is by the definition of, go to the NSG, normal subgroup. Okay, this can be converted in, this is equal to x inverse h by hang because G is an abelian. Already we say that in the first statement G is an abelian, so that h inverse x inverse is equal to inverse x inverse h ಆಗುತ್ತೆ, convert ಆಗುತ್ತೆ. So next the both x and x inverse is equal to another value e into h. So x in the properties of group ಅಲ್ಲಿ ಹೇಳಿದರೆ, the x inverse is equal to e by the properties of groups ಅಲ್ಲಿ ಹೇಳಿದರೆ, ಇದು x inverse is equal to e ಆಗುತ್ತೆ. So e is equal to 1 ಆಗುತ್ತೆ. Therefore next ಏನಾಗುತ್ತೆ, is equal to 1 into h is equal to, directly you can write h. So this small h belongs to capital H. Okay, this small h belongs to capital H. Therefore, thus we can say that x belongs to G, as usually h belongs to h. That implies x inverse belongs to h. Okay, hence we can say that h is a normal subgroup of G. Okay, see, here is your final answer. Okay, so question another, let us see once again this. Show that every subgroup of an abelian group is G. So the question what they are given, what we have to find out, there is an abelian group. By using every subgroup we have to find out a normal subgroup. Okay, so after that what we have considered here, so let G be an abelian group. So let us consider that G be an abelian group and H be a normal subgroup of G. H ಅನ್ನೋದು a normal subgroup of G ಅಲ್ಲಿ ಇದೆ. After that let x be any element of G. So x ಅನ್ನೋದು any element, or we can say that x belongs to G, or we can say that x belongs to G ಅಂತ ಹೇಳ್ಬೋದು. Okay, after that find H be any element of H, or you can also say this H belongs to capital H. Okay, so we have these both x and h. From this we have x inverse. This is by the definition of normal subgroup. By using this normal subgroup we have converted this as x inverse h. How we are considered means G is an abelian group for us, so h x inverse is equal to, we are converted into x inverse h. This is by the properties of abelian group in the groups. Okay, so x inverse is equal to e. This is by the properties of groups. Okay, this is by the properties of groups alliruva property x inverse is equal to e. If you don't know this, you have to go from the starting, from the groups definition. After that group definition we have given that properties of groups. So after that e is equal to 1, e into h, 1 into h is h, so we can say that h belongs to capital H. Okay, so h belongs to capital H. ಹೆಂಗಂದ್ರೆ ಇಲ್ಲಿ ನೋಡ್ರಿ, h be any element of n h ಅಂತ ನೋಡಿದ್ದೇವೆ. By the definition we are using small h be an element of n h, so we can say that h belongs to h. So therefore X belongs to G and X belongs to H. Therefore, X inverse belongs to G. Therefore, we can say that H is a normal subgroup of an G. Okay.